for the next finish. After the sealer dries, he sands it a little, and then applies 2 coats of traditional French polish. This mix of alcohol and shellac gives the cabinetry a high gloss finish. Once it dries, he buffs the wood with wax to enhance the sheen. The clock door, with its exotic veneer, is also stained, polished, and waxed. Then, using tweezers, he positions tiny brass hinges on the door. He presses little brass pins into holes in the hinge to secure it to the door. He files the pinheads until they're flush to the hinge. He now dips the pendulum and its weights in acid, which gives them an antiqued finish. He installs them in their compartment in the cabinetry. He now sets the clock upright and paints the back basic black. He inserts a piece of clear acrylic into the opening of the clock hood. Acrylic has a slight wave to it that looks like old glass. This small watch movement is what will make this mini grandfather clock tick. Using double-sided tape, he attaches it to the dial. He fastens the hands to the clockworks shafts, and then he lowers the dial and clockworks into the hood compartment. He signs at the back with a paint-filled pen, which makes his signature stand out against the black background. And finally, he glues a tiny tassel to the door handle. Including drying time for the various finishes, it has taken over 3 days to make this miniature grandfather clock. No small effort, but it's the little details that make a difference in a small space. It's out of the basement and into the backyard for the model train set. This trend is called garden railroading, and it merges 2 hobbies, gardening and model trains. These outdoor train sets are often larger and more rugged than indoor ones, so people can hop aboard for a tour of the perennials. These garden variety train sets have become the fastest growing segment of model railroading. People design gardens to the scale of these trains to provide the perfect backdrop. This particular locomotive is a quarter of the size of the 19th century original. It starts with a sheet of copper, cut to precise measurements with a guillotine blade. An employee then turns the crank of a machine to curl the sheet into a cylinder shape. This cylinder will serve as the barrel or outer casing of the boiler. The next worker assembles the boiler's internal components. He groups together numerous copper tubes and welds them to a firebox at one end and a copper plate at the other. He's now ready to enclose the firebox. He installs it on a base plate and then builds a protective shell around it. He then encases the heat tubes in the barrel. These boilers come in various sizes, depending on the scale of the locomotive being made. Next, a lathe spins as tools contour a bronze cylinder. This sizes it to fit a piston that sets the steam engine's wheels in motion. The cylinder on the right is the one that's just been machined. More tools transform basic steel discs into the train wheels. They make 4 wheels per locomotive. The next worker inserts a pre-cut sheet of steel in a device which, when activated, bends it in 2 places. The folding action shapes the sheet into the locomotive cab. Then it's into the paint booth for 7 coats of epoxy paint. This gives this model train cab a heavy-duty gloss. With a steady hand, a painter now applies plastic tape around the perimeter of the cab to create a kind of linear stencil. He arcs the tape at the corners to soften the look. And then he brushes 2 coats of oil-based paint into the taped stencil. He allows 3 days for each coat to dry. Then he peels off the tape to reveal the crisp, clean lines that now frame the cab. He adds a black border next to the white to give more depth to this custom paint job. They carve a piece of bronze into a valve to control the flow of steam to the piston. They assemble the locomotive chassis and paint it. They install the wheels and the network of pipes and parts that make them turn. They run compressed air through the system to confirm everything works. The worker adds a little oil to lubricate the wheels and the rest of the parts. He then opens the steam chamber to check the valve and piston action. which is the driving force of this steam locomotive. He pulls the forward and reverse lever to confirm that the wheels run in both directions. He applies the brakes, and the wheels grind to a halt. Now that everything on the chassis has checked out, this steam locomotive is ready for the chimney and boiler. The steam dome and safety valve go on next, followed by the cab and roof. This garden steam locomotive is now complete. A worker shines a light through the boiler tubes to examine them for any obstructions. He pokes a brush through them to be certain, and then gives them the all clear. It's time to fire up the boiler using real coal. Hot gases flow through the tubes to heat the water in the boiler. Like a big kettle, this locomotive builds up steam. The pressure increases until it's ready to roll. Aboard one of these garden locomotive replicas, one can relive the heady days of steam engines. A hovercraft rides on a cushion of air created by powerful fans. This enables the craft to travel over both land and sea. The concept actually dates back to 1870, but it wasn't until the middle of the 20th century that a British inventor perfected it, and the idea got off the ground. This model of hovercraft is equipped with a single fan. It both inflates the skirt, lifting the vessel about 25 centimeters, and creates thrust to propel the hovercraft over virtually any surface. Production begins with a hull made of lightweight polyethylene. The fabricator installs aluminum skids on the bottom to protect the hull during landings on rough surfaces. He screws plastic attachments for the hovercraft's skirt into pre-marked positions on the hull. The technician drills 65 holes around the hull. The fan's air will pass through these holes to fill the hovercraft's skirt. The hull consists of a thick, hard outer layer and a low-density inner layer that makes the material buoyant. It's what keeps the hovercraft afloat during stops on water. The crew now fastens the seat base and console in the front of the hull. Once it's secure, they fit the gauge panel in its slot. The team then moves to the back of the hull to install the drive belt, pulley, and the main drive frame. This pulley will transfer power from the engine to the fan. Once they confirmed everything moves freely, they assemble the fan to the main drive frame with high-tension bolts. This duct will divide the fan's air into two streams. One stream will be directed under the craft to provide lift. The other will be routed out the back to generate thrust. They now return to the cockpit to attach handlebars to a steering mechanism. The engine can be either a 2-stroke or 4-stroke, depending on the amount of power desired. They connect it to the drive assembly and protect that connection with metal casing. Once the engine has been bolted into place, they equip it with a radiator, an air filter, an exhaust system, and a waterproof box containing the electrical components. Then they connect the fuel tank to the engine and cover the engine with a polyethylene hood to keep it dry. They install seating, including a rear bench that accommodates 3. Then the installer attaches 2 rudders to the fan duct. He links them with a bar so they'll move in tandem. These steering parts are made of marine-grade steel to prevent rusting. A quick check confirms the rudders are operational. The hovercraft skirt is made of the same material used on shoe soles, sturdy polyurethane nylon. They assemble the skirt to the hull in 65 different pieces. The worker loops each segment over a side bumper and secures it with a steel clip. He then attaches the bottom of each skirt piece to the little hooks on the hull. He uses plastic cable ties for this job, and there's a good reason. If the skirt becomes snagged on something, these ties will break and free that section. Then other parts of the skirt will balloon out to fill the breach and maintain the air cushion. And they also won't have to replace the whole skirt, just the section that's been damaged. After a final inspection, they take this hovercraft for a test spin. They check the steering and overall performance and enjoy gliding on air. A folding bicycle is a compact set of wheels. In seconds, it folds up into a neat little bundle less than a third of its full size. The concept has been around for well over a century, and in recent years it's on the comeback trail, as urban commuters discover the advantages of downsizing this mode of transportation. A few quick folds and this bike no longer carries the rider, he carries it. The bike can then be carted onto public transit or into the office, and that makes it a handy way to get around town. Manufacturing begins with the main part of the bicycle frame. They lubricate the rim of tubing, which makes it easier for machinery to pinch that end. The next machine uses several blades to trim the pinched end and cut a small groove. These exact cuts will enable the team to precisely install a hinge to the tube. Hinges are now gripped by a moving clamp, which angles them for contouring and the drilling of holes for bolts. It's computer choreographed to produce a hinge that will attach snugly to the main tube. Once the hinge has been bonded to the main tube, a technician checks the job by exposing it to a magnetic field. Variations in the field would indicate a flaw, but he finds none. So next, he secures the tube on a work table so a tool can make scoops in the other end. Scooping this end will enable it to interconnect with another part of the bike frame.